Okay. So now, if these elements are going to get stored in the array, so it will be stored like this array. So this is 2, and then this is 5, and then 6 will be there. Then there will be 9, and then there will be 15. So like this, it will be stored in this, right? So if now every number has indexing 0, 1, 2, 3, 4. So if you want to access this element, what you can do is simply you can give the array of let's say if you see give array of 2. So simply this will refer directly to this number. You don't need to go at a starting and find this element. But in case of linked list, if you want to access this element, you cannot go directly. You have to go from this from first element. First element will give the address of second element. Second element will give the address of third element. That's how only you will be able to access the elements. Okay, so this is called a linked list. Linked list means where each element is connected with its previous element. No element is directly accessible. Every element is accessible by this starting position. So we call this as the start or initial or whatever you say, right? Because your list is going to get started from this place, and this will be linked one by one, step by step, till the last element, and this is how it will work. Clear? Is it clear? Am I audible?
Yeah, yes, sir. Okay, sir.
Okay, please
Yes.
keep on responding. Okay, so this is the list. Now, why do we require this kind of connection? Some you may ask that we have this already well established array, then why the hell we are going to take these elements? Why? Means why to complicate this so much, right? So at initial what we discussed was, let's suppose we have a memory of this, memory of like this, right? Here elements are there, one, two, we are taking. So these are six, and again we are taking this one, two, three, four. Let's see, this is five and six. Okay, so how many blocks we have? One, two, three, four, five, six. One, two, three, four, five, six, seven. So total we have 42 blocks, right? Now, if everything is stored, let's say in the array format. So array is a continuous memory allocation. So suppose there are five elements initially at this. So five elements will take, let's say, 2 bytes. In integer is taking 2 bytes. Okay, so now five elements are taking 10 places. So this first element is stored at this place, right? These six and these four, these are the first elements. In the same way, now some so how many they have allocated? They have allocated 10. Now a new array comes, and it says that I have let's say um, 10 elements. Okay, so 10 elements are stored. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now 10 elements will require the space of not 10 elements. Let's say we'll take a smaller part. So let's say again two, three, four, five, six. So we have again 12 elements are stored. So now these 12 elements are stored in, let's say, um these 12 elements are stored, let's say, here, in this part. In this region, these 12 elements are stored. So 6 and 6 again, 12 elements are stored. Okay. And now, let's say more, um, 5 elements more are there. So 5 elements, so here they are stored in 12. So now new five more elements are there. Now these 5 elements will take the 10, right? So 10 means these 6 are taken, and then 4 are taken over here. Okay. So 10 are taken. Now total occupied space is 32, right? And what is the remaining? So remaining space is 42 minus 32. So the remaining space is 10, right? Now you have the space of 10 elements, but ten elements means 10 places. Here, let's say, here, this is 5 and 3, 6 to 8. One place has 8 elements, and another place has the space for 2 elements, right? So these two are available. Now, some person comes and he says that I want to store an array of again 5 more elements, right? So again, five more element would require the space of 10 bytes. Okay. Now you have the availability of 10 bytes, but these 10 bytes are not available in a sequence. Means 8 bytes are available here and 2 bytes are available here. You have the availability of these 10, but you cannot allocate these 10 elements because they are not available continuously. Correct? Understood? Since they are not available continuously, so you will not be allocate these elements in the way you want, right? So because of this problem, this linked list got evolved. So what linked list does is it stores the same number of elements but at different references, right? So one element, let's say, will be stored here, another element will store here, third element will store here, fourth element will be stored here, and fifth element will be stored here, right? And this will have the address of this will have the address of this will have the address of this element, and this will have the address of this element. So like this, they all will be connected together. All the elements will be connected together, and they will be able to get wherever they want to get placed. Correct? So this the concept of linked list got involved, where every element has a address for its next element, right? So in this, what we do in linked list, it is a nodes connected structure. Every element has a address for its next element, and address of each element is available to its previous elements. Okay, so these are the two things which are giving the same things. Means one, first element has the address of second element, and address of second element is there with first element. Okay, so what is available with you over here is only the address of first element, and via first element we can reach to other elements in the list. No other element can be reached directly without first element. Okay, so element of the first element is very important in case of linked list. Is this okay? Is this fine?
Uh, yes, sir.
Mila, is
Yes,
this understandable for you?
yes, yes.
Okay, so just remember these things for the linked list. So we'll one by one we'll see how we can implement these things in our program, and how we can make an interactive program with this, and this can be useful for the implementation part. Okay, HR BR, sorry, I am taking the HR BR. Okay, so now we'll see how we can implement these things with the linked list using Python. How we can implement, and how can we create such list? Okay, so this was for you to visualize that how these things can work. Now I'll give you a brief introduction on how we can create it, and how we can see how we can do other operations with this. So this is a very good point of means good things of for the understanding, and you might need a lot of practice for understanding of complete understanding of this. So just be with me, and I'll show you how to implement. Then you can implement it by yourself as well. Okay, so let's okay. So well, we are going to uh, create a structure for the linked list. We'll create a structure for the linked list. So here we'll use few techniques of object-oriented programming. Okay, till now we were using the straight programming. Now we'll use few features from the object-oriented programming to create the objects, right? So to create the object, first of all, we should define a class, right? So we'll take a class, and I'm creating a class called node, and here we are taking two values. So for initialization we are taking init, def init, and self comma data. Do not worry, you will encounter few new things over here. I'll explain everything what is that, and data, and self dot next is equal to none. Okay, now this is what I have made a structure, right? So what is this structure? This structure, like we have a structure of array. So what array structure does is array structure just creates a single, let's say you can take as a single table or one dimension table where five, six elements are stored, right? Now in the linked list, you cannot store the five, six elements together. You have to store every element one by one. Okay, so now all those elements will be connected through a link. So that link is available in this self dot next, right? So whatever the value will be there, that will be connected with the next element. Okay, and the self dot data, this is a part where the data will be available or number will be available, right? So it's not necessary that you just keep the same name. You can keep the different names as well. So self dot no you can write, and here you can write no, or here you can write number. I always try to be very clear with the indications in the program. I don't keep the values very random in order to avoid any confusion. So you should also have a practice for that. Do not make the random names or random naming conventions. Always try to create the naming conventions that are relevant. Okay, so here I am taking, because we are dealing with the data, so I am taking the name same as whatever is relevant. Okay, now what is this class? Any of you have studied the object oriented programming? Have you studied the
Yes.
object? Yes. Okay. Which object oriented you have studied? Java or C++?
C plus plus.
C++. Priyanka, you also have studied that?
Yes, sir. Python only I studied.
Okay. So you must be understanding what is class. I don't need to tell that.
Yeah.
Correct?
Mm.
Okay, I thought if you people are not aware, I should go through the definition for the class. But since you both are aware, so I don't need to tell these things in detail. Okay, so I have created a structure for this. Okay, now what I'll do is I'll just at the initial level, I'll just assign the class, and I'll assign the nodes, and I'll create a link. I'll try to create a linked list. So to create a linked list, simply what we are doing is we are assigning few values. So let's say assigning nodes in the linked list. Okay. So now in linked list, you have to assign the numbers. So you can assign the random numbers here. Here. So at initial level, we are assigning just random numbers. Okay. So here I am taking this node one. So node one is here I am taking node of, let's say, 32. I am taking, then node 2 is equal to node of 35, and then node 3 is equal to mm, node of let's say I'm taking 26, 26, and node 4 I'm taking as node of, let's say, 45. Okay, so now I have created these four nodes. Now, what these four nodes are representing? These four nodes are representing four different nodes of this class, four different objects of this class. Right? These node one, this node one, node two, node three, node four, they have become four independent object of class node. So if visually we see by diagram, so how it will look like? It will look like, so it will look like I have created four independent nodes. One is this, where 32 is stored. Okay. And I have created another node which has value as 35. Okay. It has 35. What is the value of third node? I have assigned third node. Um, where it is 26 and 45. So third node I have assigned 26. So this is the third node I have assigned as 26, and this is the fourth node I'm assigning this as 45. Okay, these four nodes these are the independent nodes. They are not connected. And at present, since we created the structure as where next part was null, so right now all these values are null. Okay. Now what our task is, we have to connect this node 1 with this node 2, node 2 with this node 3, node 3 with this node 4. And for in the next of node 4, since this is the last element, this should be null. We have to connect our structure like this. Okay, so let's see how we can do that. Um, mm, so here, since we have created these four elements, now we'll connect these four elements together so that they can get connected to each other and form a single list. So how we'll connect? We'll simply type node 1 of next is equal to node 2. Node 2 of next is equal to node 3. And node 3 dot next is equal to node 4. Right? So now by this, what will happen? Now the next part of one element will be connected with the next part of other. Right now, there is no node after node 4, then the next part of node will remain none. As soon they are created, for every node the next part was none, but as soon we executed these things, they are connected. Now node 1 is connected to node 2, node 2 is connected to node 3, and node 3 is connected to node 4. Okay, is this clear? Is this clear?
Yes, yes, clear.
Okay. So now what we can do is we can try to print this. So how we can try printing these elements? So once I have the list available, right? So now what will happen? Mostly we have an element at a starting. So node 1 is the starting element. So from a starting element will start and will take a temporary node. We'll slowly create a function also for this, but for now, just for your understanding, I'm creating it without function. Okay, for now. Okay, so let's see if I have um, taking a variable cn as current node, and it is initialized with node 1, and then while cn. Okay, and here what we'll do is we'll just print cn dot data and comma end is equal to, we'll do double hyphen like this. Okay, and cn is equal to cn dot next. Then at the end, print null. Okay, so we will execute this. So you can see here this list is created. So first of all, 32 is connected with 35, 35 connected with 26, and 26 connected with 45. If you have more, you can do more, right? Like node 5 I can do. Node 5 is equal to node of let's say 56, right? So here again, node 4 of node 4 of next is equal to node 5. Okay, so now I'll execute this. So you can see here one more element is added over here. Okay, so this is how you can create the linked list. Is it easy? Is it tough? Is it able? Are you able to understand?
Yes,
So
Okay.
next is a variable.
Next is a structural part over here. You can see here, this is the structure created, and next is a part of it. Okay, and what next is storing is next is having the address of the next element, right? So the element in current node is this, but the address in the current node is this next is having with next part. Okay.
Okay.
So like this, you can create your own structure, and you by this you can assign these, and these will be validated, right? So now the important part here is that the node 1 is the uh, contact point or access point of this. So here, just for your understanding, node 1, or you can say first element of the linked list is the first element of is the um access point to the list, right? At any point of time, if you missed the node 1, right, you won't be able to find the address of any other element. Okay, so you have to keep in mind that whenever you are working with the linked list, you always need to keep the address of node 1 or first node very safe, because this is the access point to the linked list. If you do not focus on this, you will leave or you will miss the linked list. Okay, and once you move from current node to next node, it will be highly impossible to connect back element. Is this clear? Uh, is this clear?
Yes, sir.
Okay. So now we'll do more operations in this. How we can do. So since we have created a list, now we have the different kind of operations. So what can be the operations? So we want to insert an element into the list, right? This insertion can be at the starting of the list, means we want to add a new element at the starting, or you can insert an element at last of the list, or you can also insert the element at somewhere middle of the list. Okay, at any place you can add an element, right? In the same way, you can remove an element from the list. So this also can be removal can be from starting of the list, or last of the list, or from first position. Okay, so these things can be done. So this will see one by one how we can do these implementations. Now, these things also includes what, that starting of the list and last of the list. So starting of the list is, since you have only the access to the first element. Now, when you will add a new element to the list, then this element will be the first element which you are going to add at a start. So this starting element also must move to this new element from where your list will start. In the same way, if you remove any element from the first, right, from the start, so right, like you want to remove 32. So ideally, your list will start from 35. So the 35 element should be denoted by node 1. Then only you will be able to do the justice for this. Okay. So let's see how we can do these operations. Am I going fast, or it is fine for you to follow?
Yes, sir. Okay.
Okay. Okay, to start with this, what we'll do is first of all we have to do all these operations via function, because if without function we'll do these operations, it will take a lot of time and hustle also, and it will make the entire thing confusing. So we'll make many functions. So out of those functions, one function that we are going to create will be um printing the linked list linked list, and second one is traversing in the linked list, right? Because if a number comes, how you will see that with how many numbers are there, or whether the number has been added or not. So it becomes very important to see every time to print the linked list. And traversing the in the linked list is means going to and from in the list, so that one by one element can be accessed in the list, and the position can be identified. Okay, so we'll see how we can do this task. So first of all, I'll create a function to initiate the linked list. Okay, so here I'll take initiate the linked list. Okay, here what we'll do, we'll create def init create. Okay, and here I'll just ask the user to get the value. So let's say if I want to create a new list with two, three elements, right? So here I'll take values, val, value. Okay. So here I'll give a message int in input how many numbers. Okay, we'll just ask that how many numbers do you want to insert into the linked list. Okay, then we'll do ch is equal to node 1. Okay, and we'll take we'll create a function travel also. Um, so we have to plan a lot of things to do, because now these implementations are going to be very lengthy. Till now, we have seen the small programs which were working into their own environment only. Now these programs are going to be lengthy. So let's understand that how we are going to do this planning. So let me open my notepad. Is this visible?
Yes, sir.
हम्म, क्या हो गया? Paint is hanging. How surprising. Hmm. Hmm. So, first of all, to add first of all, we have to make few functions like traveling means moving from one element to other element in the list, right? Second thing we want is, let's say I want to see the entire element, right? So we want to create a function to to print all the elements, right? Number three, now we have to create many functions. So out of that, one function will be append. What append will do? Append will help to add a new element at the last. Okay. So first of all, we are creating just these three functions. After that, we'll see how we can do. Okay. So we'll create these three functions only. Let's see how we can create these three functions. So this is initiate in initiate. Before initiating, we create a function on def append. Okay, append means append means append is a function to add a new element at the end of the list. Okay, so here we'll take, so now to add a new element at the end of the list, do we need is, let's suppose we have a list like this, right? We have to add a new element after this 56, right? Means a new element will be added at the after this, and null will be added at the next part of that new element, correct? So, but for that, first of all, we have to reach from this place to this place, right? So you have to move from first element to last element. So how will reach to the last element? So will reach through will reach till the last element with a method, with our code. So how will code that? So we'll take a append function. So this append function will work like, um, so here we will take append, and this I'll take n as the element to be appended at the last, right? So we'll start with count. Count is equal to 1, and what we'll do, while count is less than or equal to n, then we'll ask num int input, enter the number. Okay, we'll take this, and what we'll do, ch dot next is equal to ch dot next is equal to um, node of num. Okay, and ch is equal to ch dot next, and will count plus is equal to 1. Okay, so now what this part is doing is, with this, what we are doing, we are first of all, we are taking how many elements. So let's suppose a person says that I want to insert three new elements, right? So that three number will come here, and that three times this loop will run, and a new element will be added at the end of that. Okay, so this is how a element will be added. Okay, so let's see how we can plan this further. This is append is done, and one more function will take as print. So print function will take So this will be print function. Okay, and one more function will take define travel linked list. Okay, and this will be there. Cn is equal to nd, and while Cn of Cn dot next not equal to none, till what it will do is Cn is equal to Cn dot next, and then return Cn. Okay. So these two, three functions are the are required functions. Now, what is the difference between print and travel? So this is ND. Okay. So now what print and travel function is doing, they are just navigating from first element. So ND is an element which has been passed from the main function where this function has been called, right? So let's suppose here I am making the main function. In this main function, what I am doing is I am just creating a linked list. So here I am taking print, enter the if you are at some point of time, if you are not able to understand, just have a patience, because lot of things are coming from many directions, so you might not be able to connect the dot at this moment. But I am now in the next code that I am writing here, this will connect all the three functions which we have recently created. Okay, so just have a patience. I am reaching to the level where I can give you the clarity. Okay, so here I am just printing the message, welcome to the linked list. Let's create this. Okay, here I am taking just two numbers. So num1 is equal to, and here I'm taking integer input, enter the first number. Okay, and num2 is equal to integer input, enter the second number. Okay, now we'll assign node1 is equal to node of num1, and node 2 is equal to node of num2. Okay, so these two are assigned. Now what I'm doing is just node 1 of next is equal to node 2. So by this, what we have done, we have just now created a new linked list with two elements, right? So with these two elements, now what I can do is, if I use this function print ll, print linked list, simply I am using right now print underscore ll, and here I am here I am passing this node 1. Okay, node 1. Okay, so I'll run this function part and then run this part. So here first number is 45, second number I have interest 78. So now here you can see we have a list. This with these two numbers, list is created. So are we able to use this now? Is this clear? We are able to use this. Okay, clear? Yes, no.
Yes.
Okay, so we created the initial linked list, and with this linked list, now we can start the further processing. So now further processing at any point of time, if you want to print the list, simply you can use this print ll function, and list will be printed. Okay. Next, what we are going to do is we are going to append a new element. Okay, so to append a new element, what we'll do is we'll call, let's say here, this is append n is there, and here this is n print. Let's append numbers into the linked linked list. Okay, and here I'll just ask num is equal to integer, and in this integer input, how, let's ask how many numbers. So how many numbers do you want to enter in this now? So that will take from user. So let's and then we'll call append, and will pass num comma node 1. Okay, so here I am passing the number, means how many numbers, suppose 2 number or 3 number you want to insert at the last. Along with that, the address of node 1 will be passed over here. So this address of node 1, what it will do is it will give the address of this 45 over here. Okay, now what it will do is, now here this is n, and I am taking here as nd as well. Okay, so here what I'm taking, first of all, I am calling travel underscore ll, and I am passing this nd over here. Okay, so when this function is called over here, append, it will take node 1 over here along with this number, and in this n number will be accepted into n, and nd node 1 will be accepted into nd, and this nd will be passed again to this travel. So what this travel function will do, this travel function will start, because we have on only the address of this, it will start from this, and it will go till the last of this list. So when this entire function will be executed, this will return cn, and cn must be indicating to this 78 at the last. Okay, now after 78, how many numbers you want? Suppose let's say 3 numbers are required. So here I'll take ch, and this ch of next is equal to node 1, and this will be counted. So let's execute this, and now I'll execute this. So 45 and 89. So this is created. First of all, now it is asking how many numbers do you want to insert. So let's suppose I want to insert 3 numbers. Okay, so here I have given 3. So first number I am giving 21, second number I am giving 67, third number I am giving 32, and this is over. Now again, if I print underscore linked list with node 1. Okay, so now you can see here all elements are there in this. All elements are there. Yes, no? Sharmila, Priyanka,
Yes, sir. Yes, sir.
hope you are able to understand at least 30-40% of this.
Yes, sir.
If you are if you are trying to see this DSA for the first time, I don't expect you to understand 100%. Okay, if even if you are able to follow 30-40% also, that is more than enough. It's not means mostly this the in the engineering subjects, this is a very main subject for most of the students, and if they are also not able to understand this for in first time, 3-4 times they take. So I don't expect you to do at the first time itself. Okay. So simply what I am trying to do is I am making a function. So first of all, I have made this print function, which is printing this entire. So I am using that in at different places with the implementation, so that at every point I can see. Means if I would not have made this function, so every time I have to write this code wherever I am using this print. So suppose here also I would have to write, here also I would have to write. But since once I have written, now I can use just this function directly, and this will be printed directly wherever I want. Okay. Is this clear?
Yeah.
Give me a minute. Okay, so where I was. Hmm, where I was. Is this? I hope this must be clear. I'm now removing this now. Okay. So now by this we are able to insert a new number at the last. Okay. Let's suppose if I want to insert a new element at the starting. Give me a second. There is some noise. Come. Okay, so now what I am going to do is next what so this is what we have inserted a new number at the last. Okay, again let's execute this. So first number is 45, second number is 78. Now I want to insert three more numbers. I'm taking 21, 34, 67, and you can see here this is inserted. Now what I want is I want to insert a new number at the beginning of this, at the starting of this list. Okay, so at the starting of this list, what we can do at the starting? So how we can do at the starting? No, so we'll take we'll make a function to insert a number at the starting. So function to add a new element at the starting of the list. Okay, def insert start. And here we'll take just the number. So let's say I have I'll take just an ND only, and here I'll ask num is num is equal to int input, enter the number. Okay, and now what we have to do is we have to make a node. So new will take new node is equal to node of and num. Okay. So this node is created. Now this node needs to be added at the starting. So before 45, this node needs to be added. Means the address of this 45. The address of this 45. So this address, this is denoted by node 1, which is node. So here it is accepted as node. So what we'll do is new underscore node is equal to nd. Okay. So what this will do is the next of this new node will be this nd. Now this nd needs to be moved again to um, in the first position. So nd is equal to new node. Okay, nd is equal to new node and will return again nd. Okay, so here we'll do node 1 is equal to and insert underscore what was the name, insert star and node 1 and print underscore ll node 1. Okay, here we'll start from this. Okay, now we'll execute this insert. Okay, I have not executed this part. I'll execute this part. Now we'll execute this. Okay, so now I'll enter a number. Let's suppose I want to insert a new number 55 at the starting. Okay, so this has not come. 55 is not still inserted. So let's see what is the problem. Um, node 1, node 1 insert start node 1. Okay, so if I print node 1 over here, print node 1, enter the nd num ठीक है ये new node. Oh sorry, new node of next, and this is new node of data, new node of next, and then yes, now it will work. Okay, so now here I am giving 55, insert a start. Okay. 55 from why it is getting error again, new node. Okay, yes, now it has come. Okay, so what we have done is simply I have created this number that you already know, and here I have assigned this nn to the node, and at the next of this I have assigned this node. So if diagrammatically, if I want you to visualize this like, so you can visualize it like diagrammatically, how you can visualize is, let's suppose you have a list like this. So you have one element. You have one element 45. Okay, and at the next of 45, a new element is added. One element is added as, let's say, 62. Okay, and at the next some other element is there. Let's say this is 21. So you have a list like this. Okay, now at the end of this is null. Okay, and this element is your node 1. Okay, and you have address of this element only. All other elements are accessed via this element. Now what I want is, I want a new element to be added before this, and I want this new n1 needs to that, so that your list can start from that. Okay, so how we'll do that? Let's see how we can do this. So first of all, will create a new element. So now I have taken a number as 55, and I have created this 55 over here. Okay, so this is created. Now at this point, when this is created, this part is blank. Now what my job is, that I should connect this to this, right? So with the sorry, with the, where is my program, with this statement, what I am doing is, I am just creating this, and I am creating um I am creating this element with this element. This part is created, right? Now this, when this part is created with this element, what I am doing is, new node of next is equal to nd. So this is rnd. So new node of next is connected to this now over here. Okay, now when this is connected, is, but still your list is starting from this place only. So now next job is that this n1 and node 1 should refer to this. So for that, what I'm doing is, nd is equal to nn. So when I'm doing this, nd is nn, so this is my nn, this is my nn, and this is my nd, right? What I'm doing is, nd is equal to nn. So now this nd is moved to this nn. So now nd and nn both are representing this element. So in previous element, this is connected. In this element, this nd is moved from this place to this place, and now your list is starting from this node 1. So now your this is node 1. Okay, are you able to understand this,
Yes, sir.
Sharmila?
Yes.
This is more logical, and tricky part is there. So just understand it as much as you can. Okay, and when you will practice, you will be more confident in doing this. This part clear? Is this
Yes.
part clear?
Yes.
Yes, sir.
Okay, great. Don't worry, I'll share this code mm, on your group, so that you can understand this, and try to make it by yourself as well. Right now, the third thing is, we are going to create a function. So we have understood how we can create at how we can insert a number at the last, and how we can insert a number at the beginning. Now we are going to insert a new element at certain position. Okay, so def insert position. Okay, and here again, I'll just take um, POS and ND. Okay, I'm taking these two. Okay, so POS position I'll take from the external source, and ND is the starting of the list. Okay, Now I am taking this Cn current node is equal to ND. Okay. Current node is equal to ND, and now what I'll do is I'll travel this element till the number of elements reach to this position. So I'll take a loop while um, and here I'll take the count as well. CNT is equal to 1. Okay, while um, CNT is less than equal to position minus 1. So why I am doing minus 1? I'll explain it in some time. So while this position minus 1, what will we have to do is Cn is equal to Cn dot next, and Cnt plus is equal to 1. Okay, once this is done, what we have to do is, so let's say is my this screen visible? No, this paint screen is visible.
Yeah, yeah. Yes.
Okay, so now let's see, we have four elements. This is the first element, this is the second element, this is the third element, and this is the fourth element. Now what I have to do is I have to insert a new element at this third position. Okay, so let's say I have a new element called 21 and no, not 25, and this 25 has to be inserted at this place, right? So we have this 25. Okay, so what should be the ideal scenario? In ideal scenario, this should be connected to this, and this should be connected to this. Correct? Correct? So when I have to connect these two, right? So when I have to insert a new element at 3, then ideally my loop should start at whatever the position. So this is the third position, so my loop should stop at second position. Means at here my loop should start, right? So that's why I am doing this position minus 1. Okay, so this position minus 1 I am doing because of that. Okay.
Can you repeat this?
Okay, let me rub this. So what is the scenario is we have to insert a new element, which is, let's say, 25. So I have made a node with 25. Okay. Okay. So what should be there after I insert when 25 will come here. So 25 will be the third element, and this will be fourth element. This will be fifth element. Correct. And 20 next of 25 will be connected with this. Next of this 45 will be connected with this.
Yeah.
Correct? Right? So when I have to insert this 25 at third position, ideally my loop should stop at this position, right? Then only I can refer this from this element to this element.
Yeah.
So now when I have to insert this, what I have to do, suppose this is n new node, let's say. So n of next, n of next, n of next will have the address of whom? This 45 of next, because for right now the address of 62 is there with 45, right? So this is the current node, this is the new node, and this is the next node, right? So and nn of next means this next will be filled with the address of cn current node dot next. Okay, and then current node of next will be nn. Correct? Correct?
Yes, sir.
Okay, so this is only will we are going to do the implementation in our code. Let's see how we are doing. So we have stopped this as position -1 current. So when this loop will be ended, this loop will stop at this 45. Now what I have to do after stopping this loop, what I have to do is, first of all, I'll make a new node. So num is equal to integer input, enter the number, will take this number, and nn is equal to node of nn is equal to node of num. I'll make it here, and here what I'll do is nn dot next is equal to cn dot next, and cn dot next is equal to nn. Is this fine? Is this fine? Okay, now I'll give a number. So print enter the position for the number. Okay, here I'll ask the position. Um, Position is equal to int input. Like this, I'll ask the position. Okay, and then I'll call this insert POS. Insert POS. Here I'll pass position, comma, node 1. Okay. So let's say we have a list like this, and I want to insert a new element at fourth number. Means after 78, I want a new element. Now, so let's say now let's execute this, and after this we'll print underscore ll node 1. Okay, execute this. So I want at fourth number, I want okay, I have not execute this. First I have to execute this. Now this is executed, this now this will work. So at fourth number I want to insert, let's say 60. Okay, so ये एक आगे चला गया. Okay, we are using Python, so we have to do it position this less than, not equal to. Okay, we are using Python. That's we have to remember. Okay, so enter the position at 4, and I am taking 60. Okay, so now see 60 has come here. Okay,
Yes, sir.
is this clear? I know there must be a lot of confusions right now. Is it clear somewhat? See how much big function we have made today. So in linked list, there are very long functions are there. So in next class, I'll show you how you can make a entirely integrated program in this, so that everything you can track step by step. Okay.
Okay.
Are you clear with this insertion part?
Think so.
Shamila, are you asking something?
I said yes, I think so.
You think so? Okay. Great. No worries. I'll just share this code over the chat. I'll share the code directly, so that you can make your own program and you can test this one by one. and you should not feel that this is something out of the world. It is actually, it needs a lot of practice, and once you will do the practice, you will gain the confidence. No worries. Okay, so we'll keep it at this for today, for you to absorb this, because a lot of logical things are involved over here, and once you will implement it by yourself, then only you will be able to understand that logic. Okay, I am not sharing the full program. Let me save this anyway. Linked list. I am not sharing you the full IPYNB file. I am just sharing the code, right? Let me share the code right away. This is the first one, and this is the calling of all those functions. This is the calling of insert start function, and this is the calling of insert position function. So everything is there in this code. Uh, okay, just try to make your own code by following this code. Okay, just try to understand the logic, what is going on in this code, and how this is getting executed, and keep the diagrams in mind, um, so that you can understand it better. Okay,
Okay.
Okay, sir.
is it was it too heavy for today?